Hey, everybody, and welcome to The Index. I'm your host, Alex Kahaya, and this week I'm excited to have Riad Wahby, who is the CEO and co-founder of Cubist, a hardware-backed key management platform for low-latency signing on any blockchain. I was taking a look at your website, find the technology to be super interesting and meaningful, especially if you've been in this space, you kind of understand the importance. Thanks for being on the show. Would love to kind of just dive in there, but appreciate you having coming on today.
Yeah, appreciate you having me. I'm excited to be here.
So, why are you building this? Like, what's your why for being in this industry, and how did you get here?
Yeah, so maybe I'll answer those backwards. So I started out long ago. I was doing something completely different. I was an electrical engineer. At some point, I got into cryptography, quit my job, went to grad school. And ended up working on like zero knowledge proofs. And this was a long time ago. This was like actually over 10 years ago now, at which point they were useless. Nobody cared about them at all. We would get these, reviewers reading our papers saying like, yeah, come on, this is cool, but who cares? And then suddenly people cared, right? Suddenly in the blockchain space, it was, look, there's these amazing applications. And so that's really kind of what pulled me into to Web3. And I was working on my PhD with my advisor was Dan Bonet, who's like sort of into everything Web3 related. He's fantastic, and so he had all these super interesting problems and projects for us to work on. We worked on things like anonymous airdrops and roll-ups, and we actually ended up writing the standard for the signature scheme that's now used in the beacon chain for Ethereum. So we kind of worked on all this stuff, and the whole time, it seemed like there were a few kind of nice things going on, like this cool crypto is getting used. People care about this stuff. They care about security. They take everything seriously. And then on the other hand, it seems like, oh my gosh, it's so hard to build. There's so many hacks. Like, how can we kind of make this better? How can we bring some of this stuff to the developers and to the end users and just like make Web3 easier to use for everyone, developers, users, everyone. So that's really what kind of got us into this. We were thinking about, okay, where are the problems? And we actually started out, sniffing around problems around building cross-chain applications. And we talked to tons of developers and asked them about their experiences and users. And what we found as we did this was the actual problem that everyone told us, no matter what, consistently, everyone said was, it's super scary to manage keys. It's super scary because, it used to be easy. There were two of us. We sat at a kitchen table. We had our ledgers. All of our keys were on there. And then, we got more developers because we were successful. We added more chains because we're, crossing between Solana and Ethereum and a bunch of, EVM L2s and whatever it might be. And so now like everything explodes. It goes from like, let's just make sure our ledgers are okay to like, oh my God. And so we heard these horror stories. We heard stories about people who, there's one person at the company that had all the keys on one laptop, and that laptop was the goods, right? And like, God forbid that person gets hit by a bus or like decides to, turn evil or whatever. And then we heard from the other side, like people who were at companies and they were the one with the laptop. And then they left the company, and like 6 months later, nobody had asked them for the laptop back yet. And it was like, oh my gosh. So this is really what got us into this. Like, how do we build a infrastructure that lets people manage their keys without giving up performance, without giving up control over the keys? Basically, we wanted it to be, security makes your life easier, not security makes your life harder, which I think is what everyone thinks of when they think of security. So that's how we got here. That's what we're building now, is, all of this stuff around making it easier for, somebody to manage keys on behalf of their users without owning those keys. Like, the user owns the key, but I can help you. I can help you to be safe with it. Or I have a company and, I have tons of keys that my employees use. I have different divisions in the company and they have access to different sets of keys. Like, that's a huge nightmare, right? Like in Web 2, we have all of these companies that are building around access control and access management and all of this. And we just don't have that yet in Web 3, or we didn't. Well, now we do with CubeSigner.
Yeah, that's super interesting. I know this problem really well. Haven't been in the space for a little while. And it's interesting that you brought up like the differences between, like, I'm in my kitchen and I'm showing my dad how to like self-custody on a ledger, right? Is very different from, hey, we started out as two founders building an exchange, for example, and we were just trading like Bitcoin and that was it. And then one day And it happens faster than you think, right? Like you wake up and like 2 years later, which feels like 1 month, you've got, an exchange that's doing billions of dollars in volume across, 50 different networks. And there are, we saw this with FTX, right? Like things are not always as like secure and safe as you would think they would be. And some of that has to do with like, obviously in that case it was nefarious actors, but in a lot of cases it has to do with like, hey, there just wasn't either a best practice or that literally the technology just didn't exist to make it easy enough for you to have a good security practice in place. So and teams go to great lengths to solve this problem manually. So for a company like Cubist, it's like there are people who see the problem and they actively try to solve the problem themselves, probably spending like both time and money to do that. But I'm really curious to learn more about your solution. It's not like a multi-party computational wallet product, right? It's something different than that.
Yeah, absolutely.
It uses hardware. So like break that down for me. Cause, and I'm not as technical as you. I'm not like a cryptographer or like, also I know Dan Benet, by the way. I've met him before. I mean, I doubt
awesome.
he would remember me, but like,
Great.
yeah, he was an advisor to Orchid, which is a company that I used to work for back in the day, back in like 2016. But anyway, can you break down for me, like, how does this product work?
Absolutely. Yeah. And by the way, what you said absolutely resonates. Like this idea of, teams that take this seriously can spend infinite time on this. Like if you're managing your keys look, we have a product. We have like an amazing team of engineers. We spend 100% of our time on it, and that's still not enough. Like I want 60 hours in a day so that we can get more done, right? Like there's just a lot to build. So but let me break down this notion of like secure hardware. Where does this fit in with the MPC world? So I think what we've seen in the space historically has been, a really big push around, MPC is the solution that, you should use if you're managing keys. And frankly, it's a great marketing play. It really is, because like the people that are in the market, especially in the last few years, we're, all of us really, we're, sort of bleeding edge, right? Like everything that we do, we're doing the latest, most cutting edge, like we're just pathologically bleeding edge, really. And so MPC is like, oh my gosh, it's this new thing. It's amazing. That's a great sell to somebody who's pathologically bleeding edge. But there are a lot of sharp corners here. So one of them that we've seen over and over again is you pay a ton in terms of performance. We see companies out there with products where, you want to generate a signature. Sure, 10 seconds later, maybe you have a signature. And, for me, if I'm just like sending somebody some money, okay, fine, 10 seconds doesn't matter. But for a lot of companies, it's like, look, you're trying to push a lot of volume. You're trying to push the minimum latency that you can. That's just not acceptable. And I think, frankly, like what we tend to see is that performance hit turns into a security hit, because people say, you know what, I can't waste the 10 seconds. So what I'm going to do, I'm just going to have a key locally, and then it's fine. It's okay. And then unfortunately that key, like it's the value that it's storing grows and grows and grows because you're very successful. And now you've got a hot wallet that's controlling whatever, hundreds of millions of dollars. And you're like, oh, how did I get here? But now you can't go back, right? Like you can't go back to something that gives you worse performance, because the reason that you got there in the first place was the good performance. So like the kind of first thing is like, we got to be able to give you performance without compromising security. So I think the other thing that we tend to see in a lot of MPC deployments, and we've seen this, in the industry as a whole, like in big hacks, we have this notion that, well, we have a consortium, you need a majority of the consortium in order to take some action. And well, okay, it seems like that helps you, right? Like as long as they're not colluding, as long as they're acting independently, maybe adding more players makes us more secure. But I think there's something crucial left out there. And that is basically you need to assume that the bugs in your software are not correlated with the bugs in the other people's software. And unfortunately, what we tend to see is everyone's running exactly the same software. So like if I have a bug that lets an attacker make me take the wrong action, you also have the same bug and the attacker can make you take that action too. So like where did our independence go? It was never there. And by the way, the Ethereum folks are very worried about this. So what we've seen, right, we have, there are these websites that look at things like, well, how diverse is the set of people who are running, the execution clients, the beacon node clients, like how diverse is the software that we're using to run our chain? And Ethereum cares a lot about that because they've actually had problems with it. Remember last year, there was an issue where the chain kind of halted because one of the clients had a bug in it. Fortunately, it was only one of the clients that had a bug. And so things didn't go too haywire. They were able to fix it and kind of unstick things. But this is the kind of problem that you get into when you assume that the failures are uncorrelated when they're really not, because we're all running the same software. Okay, so I've said a lot about MPC, but let me talk about secure hardware, and I promise I won't.
Well, hold on, like, before we get to go too far, like just for people who are like non-technical, like multi-party computational wallets are attempting in some ways to solve some of the same problems that you guys are. I think they are typically more bent towards allowing users to like create a wallet for an application with just like their email and like to make the user experience like easier, right? Now, if you use something like Fireblocks, there are developer tools and ways to leverage their MPC solution that enable you to do like more programmatic things like signing transactions on behalf of a user because they clicked a button or something like that. But at the end of the day, it is software, and it typically, the way these things are architected, and correct me if I'm wrong here, this is my understanding. The way these things are architected is like there's usually multiple parties who hold the keys, the private keys to that wallet that gets created when the user like logs in with their Gmail account and creates a wallet on their behalf. And this enables you to not have to worry about maintaining seed phrases, which is like something that people use to as like a recovery option, right? If you lose your wallet, your hardware wallet or something. And so like that's basically how MPC works, right? And that's not, you guys have something different.
There's sort of a flavor of that. I think what you're saying is, yeah, absolutely. What you're saying is true, with a couple provisos. So really the idea of let's get rid of seed phrases, let's allow users to log in, all of those things are orthogonal to the technology on the back end. So the back end could be based on MPC, it could be based on hardware wallets, whatever it is. Like really kind of a nice UX is, of course, you don't have to worry about a seed phrase. You don't have to worry about, if you lose this thing, oh my God, what happens? Like you lose all your funds, maybe that sort of thing. Everyone wants to get rid of that. And by the way, CubeSigner provides exactly that service. We're the system that backs the Avalanche first party wallet, which is called Core Wallet, that has exactly this, like log in with Google.
Cool.
So that's kind of orthogonal to the sort of the back end tech, which is like, how do you make sure that the keys are secure? And exactly as you said, with MPC, generally the idea is we take a key somehow we've generated a key. And we have, maybe let's as an example, let's say there are 3 servers. We're going to split the key into pieces, and each of the 3 servers gets one of the pieces. And then any 2 of the 3 servers has enough information to acting together to generate a signature for that key, right? So it's like this is like a 2 out of 3 MPC type system. And there's a lot of different technologies that go on in the back end there, but that's fundamentally what it's about. Is we take our key, we split it into 3 pieces, we give those pieces to 3 computers, and as long as 2 of them remain honest, life is okay. But we need 2 of them to work, and there's a lot of kind of complexity there. Okay, so let's talk about the alternative, which is what we build on, which is secure hardware. So secure hardware is basically, I mean, in a sense, it's the more boring technology. It's like we've had it for a long time. We know how it works. Banks have used it forever. In fact, banks have been required to use it forever. Essentially all of e-commerce is built on secure hardware. So things like securing TLS, the root server certificates, everything that you can imagine in e-commerce somehow comes down to, is this like some keys stored somewhere inside of secure hardware? So secure hardware is like this super, super battle tested technology. And what goes on in secure hardware is this: we build a device that holds cryptographic material inside. And the device is designed in such a way that essentially the keys can't escape it. So the keys are generated inside of this hardware. They're kept there forever. This hardware resists people trying to extract the keys. It certainly doesn't have like an API for me to extract the key or ask for a copy of the key. And so what that does is it takes your key, which is this like digital thing that lives in the ether, and it turns it into a physical object. This is now the key. It's a piece of hardware. right? And so that's kind of the fundamental thing about secure hardware is you're taking some piece of data and you're effectively turning it into a physical object. And now you just have to guard that physical object and make sure that people can't touch it. And life is kind of okay. Okay, that's not exactly true because of course it presents some API that I can use to, for example, request a signature or request a decryption or whatever it is that the key is doing inside of that secure hardware. And so I have to make sure that that interface is secure too. But the thing that we eliminate immediately is somebody sneaks into my computer, they make a copy of my key, they walk away, and then like a month later, oops, where'd my key go? Well, somebody's got a copy of it. And the version of that we tend to see is there's some malware that hits, 1 million machines at once, harvests everything it can, and then later at their leisure, the attackers just go through the dump and look for secrets, and then they just steal stuff, right? So that is just taken care of. Okay. The other thing that you get here is you get this ability to build sort of more complex systems around the notion of who's allowed to access the keys, what are they allowed to do with the keys. So in our case, we have a system that lets you say, I've just generated a key. It lives inside of secure hardware. So we already have these like strong guarantees about where the key is and how it can be used. And then on top of that, I can say, this key now has a policy associated with it. So for example, this key is only allowed to pay, this set of 5 recipients, and that's it. And now the hardware enforces that. So what I've effectively got now is a key that can only do what I decided it could do when I generated it, or maybe, I can update the policy as things change at my company or as things change for my use case. But the point here is I can now have this very strong confidence that my key can't do bad things because I've told it, these are the only things you're allowed to do. And that's it. And then you can take that further. You can say things like, when I log in a web app where maybe it's like a slightly less secure environment, then I have this more locked down version of access to my key. And if I log in, say, from my iOS app that perhaps is somehow stronger, maybe I'm using using some of the native APIs for authentication or whatever it is, now maybe my key is allowed to do more. So you get this kind of adaptive security notion where the key kind of does, sort of understands how am I being accessed and what does that mean about, how much I should allow. And then the final thing that I'll say here is you can get sort of even stronger, kind of even nicer notions when you start to think about multiple machines. So if I'm an end user, I go and let's say I'm browsing on my phone, I find some new dApp. I'm like, oh my God, this is amazing. I got to add a key, I got to spin up a wallet to use this dApp. Okay. I didn't have one yet. Okay, fine. So I've spun up my wallet on my phone now. Tomorrow, I'm on my browser, right? I'm on my machine. Now I want to interact with that dApp. Okay, how am I going to do that? Well, maybe I have to go to my phone and copy a key over. That's risky, right? Because if I can do it, somebody else perhaps can do it. And what we've seen is there are a lot of attacks that revolve around extracting your key in this, export path, in the, key recovery path. And so being able to use multiple devices with the same key that's protected always with the same kind of policies and hardware and all of this, that's a super powerful thing, because now that means if I log in from device 1, I get my view of the universe. If tomorrow I log in from device 2, great, I still have the same view of the universe. And as the user, I don't have to go through some risky procedure to copy secret data over from one machine to another. For example.
So wait, let me back up here a little bit and just see if I understand. So I've got a key that gets created and it's stored on this hardware, and the hardware could be any hardware. It's not like a physical device you guys sell. It's like any machine, any server.
It's actually hardware that lives. It's very specific hardware, and it lives in the cloud. Specifically, it lives in AWS. So this is like essentially a remote virtual private HSM that lives in the cloud that only you can access by whatever.
It's not like a trusted execution environment, though, right? It's like something. Can you tell me more about like how secure what the actual machine is, or?
Yeah, absolutely. So AWS has this really cool system called Nitro Enclaves, and actually they have two systems that are very important, and we use them together. So one is AWS KMS, that's the key management service. That underneath the hood is the same kind of bank grade certification hardware that like actual banks use. It's called FIPS 140 is the standard. And this is a FIPS 140 level 3 validated piece of hardware. So what that means is it's, it meets the standards set out by NIST to that it, really keeps key materials secure. So that's AWS KMS. And then the other piece is AWS Nitro Enclaves. That's exactly as you said, a trusted execution environment. It's an enclave environment. And the thing that you can do with AWS's TEE in particular is you can say, here's this key that lives in KMS. That's the bank grade hardware security module. And that key can only be accessed by a Nitro Enclave running a specific piece of software. And that software is fingerprinted by the hardware. So you get this very strong guarantee. The only thing that can touch this key is this piece of hardware, and that guarantee comes from AWS's design. And so now what this lets us do is we can say, here's the key. This is like the root of your, the root of trust. And then here's this piece of software that does a very limited set of things. It enforces your policies. It generates signatures once those policies are met, all of this. And we can just commit once and for all to a piece of software that is allowed to touch those keys.
And so that software is cryptographically proven, right? So that just using math, that this is the right ID of this software. Like that's why you avoid like malicious software from coming in and trying to pretend that it's that software.
That's exactly right.
And do bad things.
Yeah, absolutely. Yeah. So there's a cryptographic process by which we identify that software and make sure that that is the only thing that can touch the key in the hardware. And by the way, that guarantee is really strong. AWS has this really special property that unfortunately other cloud providers don't yet, and we're pushing them on this, where even the person who owns the account, like the person who like set all of this up, they can lock themselves out. So I think of this as like tearing off the steering wheel, right? It's like you set this thing up, here's the key, here's the fingerprint of this software, and now not even an administrator with full privileges can change that. So that gives you this super strong guarantee that, once you've generated your key, once you're like sort of using the system, that you are the only person who can touch this key. Even though it lives in remote hardware, you can access it from your device with your authentication.
But but in a scenario where like I get hit by a bus, how do you solve for that?
That's a great question. Yeah. So this is something that we've thought about really carefully. And actually, I mentioned this earlier, but this is actually the kind of thing where this is often the Achilles heel of a key management service is how do we make sure that there's like a continuity of business plan when something goes wrong, right? It's, I get hit by a bus, whatever it is. Okay. So the answer to that question depends on who owns the key. So if an end user owns the key, so in the case of an end user wallet, so let's say, we provide a service. Our customer is, somebody who is also providing a service. They're providing a service to their end users. That service is, here's this wallet. It's very secure. You can add policies to it. We give you this beautiful UI, and you can log in with Google. You get all this sort of really nice UX. So that's the service. And that means that each individual user owns their own key. And what do we mean to own the key? Well, obviously you're the only one who can ask for signatures, but it also means you can get your key. Like nobody's keeping it from you. You're not trapped here. You can request the key. And so there's a really, really difficult problem to handle. And we've seen this in the industry. We've seen really major attacks that revolve around going after this key export procedure. We saw something like this with Friendtech and Privy. We saw something like this with some other, bots and stuff like this, where it was somebody exports the key, maybe they SIM swap, whatever it is, boom, the key's gone, right? So that's super, super, super sensitive stuff. And so we kind of started from first principles here. And one of the things that I love about working at Cubist, about working with the folks at Cubist is all of us have been working in security for a long time. We're like, three of the founders are faculty at, in computer science and like working on, I'm a cryptographer. One of my co-founders works on software security. So like proving that software is correct. Another one works on, sort of computer security, like core computer security. And he's done things like, build parts of browsers that sort of enhance the security of the browsers against different attackers. And so, we kind of come at this from like really, really from first principles. How do we build this stuff in a way that prevents all of these attacks, if possible? Preventing all attacks is, security is about building walls higher and higher, right? So the ladders can also get longer. The question is like, how do you make sure that you have taken into account the right attacker model and you have defeated those attackers? And so the model that we've come up with for user export involves multi-factor authentication. It involves a notification to the user, hey, somebody's trying to export your key. You can come back and finish the export in 2 days, but between now and then you can push cancel and it'll never happen, right? So making sure users know what's going on, making sure that users need to authenticate in a strong way in order to request that key. These are the kinds of things that the industry needs to move to, and that we have moved to prevent attacks like key export and stuff like that. So that's for an end user. But what about for a company? If I'm running an exchange, I have all my keys in CubeSigner, and now I want to make sure that I have a continuity of business plan. For that case, we actually have a different export model. Again, we came up with this from first principles. It involves the customer owning a set of hardware tokens. We use YubiKeys because YubiKeys actually prove their own authenticity. You can get a cryptographic proof from the key, which is really cool, by the way.
Yeah, that makes sense.
And so we use YubiKeys, and we have this model where every time the customer generates a key, they get a cold storage ciphertext that only they can decrypt using their hardware keys. And now they can keep those keys in a safe. They can have, access procedures around those keys. We've seen people go through SOC 2 audits where, the auditor wants to know, how are these keys held? Where's the, who has access to them? Stuff like this. That's all really important stuff. And this is enabled by this really, really carefully designed export model. So yeah, look, this is the keys to the kingdom. Oh, no pun intended, but like making sure that you can get the key, but that nobody else can. I mean, that's super hard, but coming at it from first principles, I think we have a really, really good design here.
Look, this is super interesting. I'm kind of curious here, like more on the personal side. Like, how did you start this company? What's the genesis story? I know you've been working in this space, but this is a very specific problem.
There's a little bit of so I mentioned my co-founders, Fraser and Dayon, are both like faculty, and so am I. And when we were all in grad school together, we worked on all kinds of research projects together about, security of this, security of that. And so at the end of grad school, we were like, there's got to be something here. And okay, if you ask them, I tricked them a little bit. I'm sorry. Because we had this really cool idea that was really like straight down their alley, like perfectly. This was exactly what both of them wanted to work on. It was like, you got these like secure compilation, and we got this problems of like making sure that programs are correct. And we started out thinking about this. And then I mentioned this earlier. We talked to tons and tons of customers, and all of them said basically like, that's pretty cool. I like that. But like, I got worse problems. And so accidentally it became this problem that I love, which is like sort of a combination of networks and cryptography, which is like my spirit animal. It's like everything that, like all the research I've done somehow touches one or the other. And so we started this, we started thinking about all these like hard problems in the space. And then we realized, wait a second, we're three nerds in a basement. Like, how are we building a company? And fortunately, I think like the only thing we can give ourselves credit for is just having the self-awareness to say, we need somebody who actually knows how to company good. And so our fourth co-founder, Anne, has 10 years in fintech. She was a COO. She ran anti-fraud for like a really high risk fintech vertical. So she's got like all this amazing experience running a company, like keeping stuff secure. Like she's sort of our counterpart on the like policies and procedures and operations side. And really, she's the hero of this story. Like she's the reason that we have a company and not just some really cool software from like three nerds in a basement. So really, I'd say I
love that story and the acknowledgement. I think that's really great. I appreciate that. As the non-technical co-founder of my company, I appreciate that a lot.
Oh my gosh. If you're a technical co-founder and you're listening to this, just like for 10 seconds, listen to this. You need somebody who knows how to make a company run. A company is a machine. And if you, as a person who's never run a company before, don't know how to build and run that machine, you will not succeed. Like you can make the most beautiful software in the world and it will be Betamax or whatever other like more recent example there is. Like a non-technical co-founder like is your ticket to a company that works. So Alex, thank you for being a non-technical co-founder. Like, this is important. This is like, companies don't just like spring out of thin air because somebody had a cool idea about some code.
Yeah. My contribution is, I mean, I tend to, I'm like really good at strategy and I understand a lot of the technical challenges in our space. So I get that, but my bigger, like my more important skill set is more to do with like partnerships and customers and revenue and like bringing the right people together around a strategy. Like I always tell people, like, I connect people with strategy. That's kind of like my core strength. And, I think that a lot of people who might be listening to this show don't realize that they have that to contribute. Like this industry, our space is very much like dev focused, you know, like if you're the dev founder, it's like God tier. But you know, a lot of like behind all those dev entrepreneurs are also like a non-developer usually, or someone who has that skill set. I think it's like pretty rare that they have both though. Cause you have to index, you know, towards one or the other. It's kind of hard to do both, but yeah, very cool. So we're kind of getting to the top of the show here, and I always ask the same question, but like, what have I not asked you that I should have asked that maybe you wanted to talk about but didn't get to yet?
Oh, geez. Okay, let's see here. So actually, maybe this one's too boring, but like, I like to think about like, where do we go from here as an industry? Like, what is like, how do we, so right, there's been this thing for 10 years, 5 years. Like, how do we get the next, billion users onto the platform? And I think all of us should be asking about that, because like, we don't exist without users, right? Like, we could build the most beautiful stuff in the world, and like, there could be, 500 of us just all looking at one another like, yeah, nice job, you built some good stuff. Mm-hmm. It's like, who cares, right? So like, where do we go? How do we get there? And I think, if I can answer my own question, if that's okay, is that okay? Okay.
Yeah, go for it.
I think the thing that we've done really well as an industry, and I think this is a slightly heterodox answer. I think the thing that we've done well as an industry is come up with cool stuff to do. And I think the thing that we've done badly is tell a story about the good stuff that you can do, right? There's all kinds of cool. So like last week, there was this big announcement that like California DMV is, putting license plate or car titles or whatever it is using blockchain for that. And it's like, okay, is that a gimmick? No, I don't think so. I think that we have actually built like collectively the blockchain space, the Web3 space, has built a set of technologies that is really good at solving problems that real people have around, provenance, data, like making sure that we know the history of something. That's really important. And if you've ever like had a car with a lost title, you will appreciate that like the existing systems for doing this suck. Right? Like it's somebody digging through a file cabinet somewhere. That's just like, here we are in 2024, right? So improving systems like that, legacy systems with blockchain technologies, like we've got the solutions to these problems, and we have to do a better job of communicating them. So I think that's one thing that we do, is just better job of communicating these awesome applications. And the other one, really the billion users, is we have to make it easier to use. And everyone says that, but let's think through this. So like this year, I don't know, the first time I noticed it was at ETH Denver. This year, like Bitcoin is exploding, right? Like people are coming back into it with like this huge, like, oh my gosh, there are all these new applications. There's Babylon, there's staking, there's like this amazing stuff. And they kind of run into a wall, because we've all kind of gotten used to like, Ethereum's UI or whatever, insert your chain here. Like all these UIs are like, they're kind of crappy. You got to like suffer for a while to like, until you learn some stuff. Yeah. But like all those people who have suffered for a while now run to the like teeth of Bitcoin, and it's like, good luck. Like it makes the UI and UX of like basically every other chain look amazing. Right. So like, and I'm not really dumping on Bitcoin here. I have a lot of love in my heart for Bitcoin, but like this is an example of like, actually, this is an example of how we've evolved, but it's also an example of how we need to keep working on this stuff. Like we need to make sure that like when this cool technology is built, like we need the documentation, we need like a UI and UX that actually responds to real users. Like I can't tell my dad how Taproot transactions work so that he can like go and like make a Babylon deposit, right? Like it's just like, okay, we're going to start with the sand that's used to build the processor that's used to implement the cryptography. It's like you have to know the whole stack to get anywhere, which is just ridiculous, right? So I think what we really have to do is like understand what the important things are for users, and that partially means make some decisions for users. That's part of the good UI UX design is smart defaults. Make sure that users have choices if they need them, but have a smart default where it's not just here's the landscape, go explore, right? We need that. We need ways to explain to people what they're doing, why they're doing it, and in some cases to just really just abstract away that complexity. And I think if we can do those two things, if we can tell better stories about the applications, and if we can abstract away all of the awesome technical details that all of us love, but which for end users are basically just a turnoff, why are you telling me this? I think then we have a killer combo. We actually have a set of products that people will want and will use.
Awesome. Well, thanks so much for taking the time today. It's been a really great conversation and was fun to learn more about Cubist. Appreciate you being here.
Alex, thanks for having me. I think it's probably come through that I'm excited to be here. It was a fun conversation, and I'm looking forward to our next one.